Hey guys, welcome back to the next video. In this video, we are going to talk about more advanced architecture in terms of your Docker. Now, I think this is the last architecture we're going to look at unless something changes in the future. So let's just go ahead and have a look at it. Let me zoom in further. So let's just go from the bottom. So you know that this is a container. You know that there is this Linux kernel feature which enables you to work with these containers. So the namespace and C groups are everything about creating containers. So that is something which we discussed earlier. We've also seen what is the namespace and C group. So that's also something we've discussed. Now we will talk about run C in a single in few minutes. We will understand this training is more or less focused about run C and container D. What is actually the purpose of having container D and run C? Both are OCI. So I'll just tell you about that in a short period of time. So let's start from the beginning. So the Docker CLI is what you will be using in terms of Docker engine when you're using it on a non-production system. So when you're going to use the Docker CLI, you're going to use it as a non-root user. So that is something which you need to understand. And there is a preparation for you to prepare yourself to become a non-root user and work with non-root user. That's a thing which we will see on the hands-on. And then you have the Docker D service itself over here, which is a daemon which runs on the background on the system, which is basically when you start the Docker service, the Docker D service is Docker D daemon is going to get started and it's going to run in the background. So till that we are clear. There's no questions, right? So now let's try to understand what is container D and what is run C. Why do we have two OCIs over here? Because we know for sure there is no CRI involved in this situation because we are not connecting with Kubernetes or a container orchestrator at this moment. Docker itself has its own container orchestrator called Swan, but we're not talking about it either at this moment. So we are talking about the OCIs at this moment. So we have two of these OCIs as part of the Docker container. In the further down the video, we will also compare Docker container with Podman. Podman uses similar kind of architecture, so you don't really have to, it doesn't differ much from Docker architecture, so it's going to be much easier for you to understand as well. Now, both the container D and run C in the container ecosystem might seem like a redundancy at first, okay, because they both are the OCI components, which is part of your containerization, as they both play the similar roles in container management. It may look as it's a redundant service, but it is not. It serves completely different purpose, and as they are part of the layered architecture of managing containers. I'm going to tell you about the significant differences between these two OCI objects, which we are discussing about. First, let's talk about Container D. Container D is an industrial standard container runtime that provides high-level API for container orchestration platform for Kubernetes. So as you can see, one arrow from here goes and connects with Kubernetes, right? So the container D enables you to do the high-level operation. As I told you, it separates itself from the run C, because run C is more or less a low-level operator who does the low-level operations or low-level API task. So that's the first thing. It abstracts a low-level container task, making it easier for orchestrator to interact with the container. That's first about the interface. The second point I want to discuss about Container D is the image management. Container can pull, push, and manage container images, which are essential for deploying containers. It helps orchestrate like Kubernetes fetch container images from registries and store them effectively. So that's one of the tasks which containerd does. In terms of interface for various runtime, containerd serves as a common interface for multiple container runtimes, including runc. This allows orchestration to choose different runtime based on the specific requirement. So I would say this is a modular approach in which you are dividing the task between two OCIs, as you know that they are doing a big deal of work. So we are dividing the task, one for having a connectivity with an orchestrator and for pulling images and managing all those images within the Docker infrastructure on your system. And the other one is all about, the first point I'm going to talk about is like OCI compilant container runtime. So runc is a lightweight OCI compilant container runtime that focuses on running containers based on OCI container images. It's responsible for creating and executing container process, managing namespace, and setting up container environment. So more or less, it does the interaction with the Linux kernel than the containerd itself. In terms of standard execution, runc adheres to the Open Container Initiative runtime specifications, ensuring that the container the container launched by runc conforms to the industry standard. This compatibility allows container creating with one runtime to be run with runc and vice versa. So to have a runc managing the Linux kernel process features, or all those things, it also creates and executes container process. So that is also an important task for the runc. So the runc majorly works directly with the containers using the namespace and the C group as a feature from the kernel feature. So this is what I wanted to tell you in this video, that even though you have two OCI features which is used by Docker, each are given different variety of tasks which it will perform on its own without any interaction between each other. And containerd does connect with the runc, because that's how it should be, and it pass on information to runc and in terms of creating and executing container process. And these images would be used, which is gathered by containerd, maintained by containerd, to the runc to have these new containers created using the namespace and C groups, which is part of the kernel feature. All right, guys. So now you must have a proper understanding on Docker, what's happening on the background for in terms of working with the Docker and the containers. I hope you really like this video, and do leave a thumbs up, and I'll see you on the next video.